Hola. I never remember to this. No, I'm not center. I'm sorry. I have a lot of talk. Like that is center. Okay, that's better. That could even work. So, okay, I'm gonna wait a couple minutes more for just to give some margin in case somebody wants to see it live. Otherwise, it's gonna be on the channel anyway. Probably, I guess. Okay, I think that's kind of enough. I'm gonna share my screen. This is Linux, so it will be more appropriate to see that I'm gonna try to share my screen. In fact, I'm gonna try and share only the godot window. It should work better. I'm gonna use. Yeah, that's fine. Yeah, that's great. Oh. Yeah. So as you can see, this is quite different um, to how you see this when you download it or when you get it, and it has an explanation. Is that I've been using this setup for basically taking some nice shots and renders for a background. So yeah, I'm gonna lower a little bit the resolution because it's a struggle. I have it at maximum. Not needed really. That already looks very nice like that, even from the space, which I think is it's fair enough to say. So just to say you how this really works, because this might not be evident when you see it on the screenshots, but the altitude and the planet is real. Um, so you can modify the shutter slightly to move the camera, and you can have wonderful space shots. This is something I'm very proud of. The blue hour and everything. You can see super interesting around these parts how the colors start to diverge, like physically. They start to break, and we got these incredible gradients. Which, by the way, this is basically why you have such a spectacular sunsets. Um, yeah, you can also orbit the sun around the world. The scattering makes it so even though the sun is not hitting this part, it's not pitch black, so it still holds very well. And then we go, yeah, we can get some pretty interesting stuff and some seriously good looking effects, to be honest. This is achieved in a very basic way. So if you want to do something like this for your testings or for a menu, like I want to do it or whatever, you just have to go to your shader, my shader, and you click the version that you're okay. I'm using the half, and you're gonna search for the position. Yeah, position constant. This is the position of the camera, and usually we just take we just make it so you cannot go forward or laterally when you move, so the illusion holds, right? So at that same altitude, we now need to reset our camera, of course, and our sun. This is more similar to what you are getting at the moment of downloading this thing. So the point about this is that you can add, as I was doing here, an horizontal component in which, in this case, is a quarter of the planet radius. So you can actually look to the planet from this camera. See, you can see a full volumetric planet working. Let's go to 1,100 meters, and let's put this center again. Okay, we are in our space vision right now. I just enjoy this a lot. So. What I did, the basic altitude is not working or something. Something I fucked up, I guess. I'm sorry, I was just testing stuff. So let's go back. I have these blah 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 blah, blah clown rabios. Again, I'm sorry. I had some change there. So I wanted to show you some of the parameters that you can use for tweaking. The raylet component is what actually breaks the colors apart. So it's the reason why the sky is blue and the sunshine is red, basically. So we don't modify a lot with this because it's a pretty close thing. Like there is not much that varies. It's just an equation. But you can modify the scale height, which is it's hard to explain. But the scale height represents the point at which most of the atmosphere is, I think. There are better ways to say it, but basically when we treat it, if we start growing towards this point, and then we decrease from that point. So yeah, it's the apex. And modifying this has obvious effects in how the in which results you get. So if we go here, for example, we can see that the whole thing is giving us much more red here and here. And if we go even crazier, the light that gets to us is barely nothing because it's all getting lost in this incredible view. So just changing that, you have actually changed a lot of how this works, even something like that. So let's keep moving. Multi-scattering is just multi-scattering. It prevents it from being pitch black. For example, here, if you don't have this, it will be pitch black, and I don't like that. So it's an approximation to multiple scattering. Okay. More things. Mie absorption is basically caused by particles that are bigger in size, so they don't interact with the individual wavelengths so much, or barely nothing. They interact with the light as a whole, saying it in a way. So what this means is that they won't separate color. They will just absorb light, and this is gonna tend towards either black or white, depending on the absorption level that you use with your albedo. So albedo, that's what it does. With a very low albedo, is absorbing a lot of that light, and as we go up, this is approximately how it should behave. This is our scattering factor. It's very susceptible, so it's not something that you can use like that. We are working with this, but this is the real factor. So even that, you already got yourself like a lot of fog. So maybe try things that are a little, yeah. Have in mind that doing this is gonna make the atmosphere more complex, for saying it that in a way. So you're probably gonna need for very realistic fog to increase quality settings. In the future, we want to make this so you can make it, but that is another project. Okay, with more some samples, you see that fog that we added is getting much better. In fact, it's mostly lesson samples. We can go back, and there is not much difference. There is a difference, obviously. So now that we have that, we can, as we said, decrease a little bit, and this looks way more natural, as you can see. This is an incredible closet zoom. Again, we can increase this again. We can make the day more clear. So this is basically your fogginess, to say it like that. And the Mie height, the scale height, if we make it bigger, what we are telling the shadow is that the layer in which this phenomenon happens is much thicker. So obviously it's gonna accumulate weight more. You see? You can even see like that the cloud, we go too high, we start to having some really interesting like post-apocalyptic scenarios. You can play with colors, of course. Now, once we have that, forward is the forward lobe. So it defines how tight, we're saying like that, how tight or how directional is this light? Yeah, how directional is this light? In the forward lobe, this is to say, when you are looking at the sun, we have a very concentrated halo, or is something more natural, you know? It's not disappearing. When you move it back, you are gonna start seeing the effect back there. This is usually very heavy here, but you can make it less acute and more dense to create these more kind of very foggy scenarios, even though you are straining a lead for from a physically correct environment. I get so nervous in English. I don't know what happens still. The backward is the same thing, just for the other side. So if the sun is there, you can see that we have in the opposite side the same effect. This is nice because it allows to create a more natural Mie contribution. So in that side, it's going to be very acute, but it's still going to be softly dispersing some light in the other part of the atmosphere. And the weight between the two is basically energy conservation. You could see it like that, in the sense that if that represents the shape, this represents how much light is going forward and how much is lost backwards. Does that make sense? If we make this the other way, it's gonna be way more visible. And again, Mie multi-scattering is just for when you don't see the sun, you see this white line. That's the multi-scattering doing its work. You take it away, you lose a lot of that super realistic layer of refraction with the Mie. Okay, we're almost done. Again, more properties. Ozone, this is very simple. You just set the center of the layer and the width of the layer, and it's not very visible like now because this effect is mostly visible, in fact, a couple degrees off. So you can see that okay, this is the blue hour, which is correctly implemented thanks to this. This is the result of ozone absorbing red light. So here you can see that changing the size and the center of the layer is gonna give you way different results. For example, this is an approximation of how it looks without ozone, which is the look that you get in a lot of these. And ozone really pushes the colors towards the nice direction. So it's very impressive. This is just the planet radius in meters. So if you want a little big planet for some reason, or you want an horizon that is much bigger, I don't know. That's your thing. Okay, so this is a gigantic atmosphere around a tiny planet, but we can make it so we can see, you see our atmosphere. This is our planet, and this is our 2000 meters atmosphere, and it's fully rendered in 3D. And you're gonna see that there's some pivots, the shadows and everything. They are just crazy. And I'm gonna try to make my PC explode and show it to you. You go very, very crazy here. It's kind of crazy, like. Incredible work, right? I don't know. Here you have the planet, the atmosphere. You can go crazy and do things like 250 meters of atmosphere. Oh, base altitude. Yeah, I added this. So by default, if you are at 0 in Godot, that's 0 in the real shader. So if you want your level to be at a mountain, but you don't want to move 1,000 meters up your level, you use this. So if we go to the floor, now we can appreciate much better the effects. And yeah, I just hope that you play with it and you try to find cool things to do with it. And yeah, it's physically based, but as you can see, there is a lot of stuff that can be simulated. And in the future, I would like to make like how it's called, a fragment shader, so I can process most of this stuff directly from code, along with some tools to save to loots, etc. So yeah, that's on the way, but I have to learn about baking textures and some stuff, and I cannot afford right now to spend another 3 months working on that because this one has not get any donations yet. Um, so I started already another thing to try to compensate and be able to keep existing and making stuff, which I like it, believe it or not. And yeah, that's pretty much it. I really hope that you enjoy it. I put a lot of work on it, and I think it looks great. It can be improved, of course, it can be improved, um, but I think it's good. I honestly do think is good. Okay, and don't forget that they come with our character controllers, which are absolutely ready. And not only ready, they are more than ready. They are smooth. They work fantastic. The mouse input is wonderful. It's precise. It's smooth. And yeah, as you can see, we included um, rotation for the body, so you can just replace that with your character mesh, and it's gonna move naturally according to the velocity in a very, very organic way. The camera, as you can see, is is very responsive. This is the third person one, but you also have a first person one. You just have to open. This is the Steam. You just have to open the first person Steam. Okay, and if you play this one, you are gonna see the arrow. That's because we have implemented physical interpolation manually for third person character and for the first person character, which means that the camera will interpolate its position, so it's smooth, it's very smooth, but the rotation is still handled manually, and the body is handled with physical interpolation too. It's handled with physical interpolation the other way around. So we are doing the rotation manually, so it doesn't dribble, compensating for that. But it's actually following you very nicely. Igual, maybe a good way to show this, maybe that if we go to FPS, and we go to max FPS, and we are gonna say 10, and we are gonna go with interpolation. Maybe I have to activate it. I don't know. I don't remember. To be honest, I think it's active already. Oh. Let's see if I can show you better in this scene. Oh, excuse me, I apologize. I'm doing just the opposite. I don't have to limit the FPS. Shit. What I mean is that if you go to physics, I'm really sorry. For example, if you were using a lower count, that's what I meant. It's still gonna look incredibly smooth. At least 20 FPS, or even 6 physics FPS. I'm sorry. I was like, what the fuck? Yeah, you see the collision shape is updating very, very, very discreetly, but our body and our camera is still following absolutely smoothly, which is nice. The same effect happens if you deliver with 60 physics frames, but somebody's playing at 200 FPS. They will see the extra smoothness, which is very important for the camera, because otherwise it's not gonna reflect nice. So yeah, this is it. Even at 20 FPS, it's super smooth. I recommend you that you use them. I think they are good. I honestly think they are good. We put a lot of work on them, and they're fully customizable too. That you just have to go here, and you have your body rotation speeds. Everything is commented and documented. Max camera pitch in degrees, mean camera pitch in degrees, camera distance, the camera follow speed. If you want to capture the mouse, the sensitivity, it also has controller support, in case I didn't told you that. Let's go with my controller. Oh, yeah. I think I don't have battery in the controller. Yeah, I don't have battery. Sorry. But yeah, you can see that it actually works. And yeah, that's basically what I wanted to show you. I hope that you really enjoy it. What I'm working right now is this thing. Because for the Lighthouse project, the one that is physically based, it was starting to become a mess, and yes, you can make a working mess, but I don't think it's like I think this kind of games actually deserves a very clean way to work because it makes things so much easier. The fact that Go doesn't have scenes by default, like levels or you know this kind of helpers. So this is basically a template that is gonna deliver with enough stuff that you can just use it to work your game on it. I've been working on initialization, on the splash screen system, on a scene manager. This is the UI. I'm still working on it, but it's fully adaptable in the sense that um, you see it's gonna support ultra wide monitors too. This is something I want to make clear. Yeah, this is the first version of the interface. I hope to deliver a couple more. I have started wait, that was godot doing weird things. Sorry. I have started doing the configuration and kinds of stuff that we need to do. Let me check if maybe it's that. Oh yeah, I was messing with the Windows eyes. I'm sorry. So yeah, this is how it's supposed to look actually. Anyway, yeah, video settings. It's not gonna be fully themed, but I'm gonna try to deliver it not looking like us. If you get me. So right now I'm using pop-ups for placeholders, but I don't like them. So this is gonna change. I've been working on this. I've been working on everything. And if you see here, when we play the game, we get some message, main scene initialized, splash screen loaded, splash scene skipped, and loading menu scene. If you let this thing go, it will do a fading in the menu. But if you skip it, it just goes to the menu. And this is not really hardcore. This is what I wanted to talk to you and show you. You go to globals. We have an event manager. Okay. This only contains some signals, but for initialization it contains the main ready signal and the splash finisher signal. Main ready means that the main scene has finished preparing all the autoloads or all the necessary components that is gonna need to work. We have a main, we have a word and a key component. So what we are doing from main is super simple. As you can see, we are just saying, hey, which is the splash screen that you want, and which one is the main menu scene that you want. Okay, and then we are initializing the game autoload, and in fact, I don't think I need this one now. The scene manager autoload setup, and then we are sending an event. And This is the interesting part, I think. Yeah, we have our scenes here, as I said, the splash, the menu. We have a game states, which are not very useful by now, but they will be. Okay. We have some dependencies, again, the main node and the main scene, the world, and the key. These are holders. We have a current state. We initialize to splash. I might change it to boot to symbolize the booting sequence instead of splash. I'll probably do that in fact. And here in ready, it's very simple. In ready, we are just saying set the main state, which is a splash, which is not even necessary to be honest, but yeah. Connect events. We are connecting to on main ready and on splash finished. On main ready, we just add the splash screen, and I also made an scene loader for you. So just to exemplify how extremely easy and efficient is to do this, use scene loader, load the scene, and you load your scene in memory. Now it's in memory, and then you just have to add it to the game. As you can see, this is load GUI scene, and this is add GUI scene. And this just is gonna manage the adding the GUIs where it's necessary. When the splash screen is finished, we're just gonna send a signal, which is gonna be the signal is launched from here. Okay. Sorry, I still have to fix a lot of stuff, to remember a lot of stuff. Yeah, on main ready on splash finished. Who is sending the signal on splash finished? I don't know. It's probably. Oh yeah, on timer timeout, we just send the signal. It's super simple. So as I was saying, the splash is just gonna say, hey, have we touched any button? And then it's gonna pass through as the parameter of skip it for that signal. So that's how we manage that. So if we go back to the game script, again, we are just loading the splash. When the splash finishes, we just unload the GUI scene. We can unload directly. We don't even need to remove it from the scene because this function is gonna do that for us too. So it's gonna remove the scene and then it's gonna unload it for memory. Then we enter in my menu state, and spawning our main menu is as simple as spawning our splash screen. It's just the scene manager, load GUI manager, my menu, and a scene manager, add GUI scene, the main menu. It's super basic. And skip the fade in if we skip the splash. I'm gonna work probably in a global fade in and fade out system because I think it's more helpful than trying to manage them individually in a sense. but this is working very nice as example. Then we have our main menu script, which is just this. By now, obviously there is still a lot of things to do and settings don't work, and okay, but this is the format. I have tried to be super good with the code architecture and follow all the godot official recommendations. So in the main menu node, you have these references, and already we are just gonna pass to the other panels references. For example, we have the main panel. Okay. On quit button down, we just quit. On new button down, we just hide this panel. A new panel, a new game panel, we show it. On settings menu, we just hide this panel, the main one, and show the settings panel. So as you can see, it's extremely modular and extremely clean and extremely scalable and personalizable. So this allows for do some pretty nice stuff because you don't have to worry that much. So instead of trying to fetch stuff, we just have this for dependency injection, and that's what we are doing here. We are main menu and we are injecting the dependencies. So it's very easy to create and manage interfaces this way by dividing it in panels. We have a main panel, we have a settings panel, we have a new game panel, we have a video panel, we have an audio panel, right? And we just gonna, as you can see, each panel has its main script, which manages its own state and the state of the others. And then we can just keep adding methods here, like when you move a slider, we want to change the sound effects, for example, right? And yeah, it was a little bit of what I've been doing. I apologize for being kind of nervous. But yeah, I'm super happy with this. I only been working for this a couple of days, and it's probably the most clean I have a project for now. And the scene loader is just, it fixes so much problems. Same as the event push. So yeah, I hope to publish this with some. The splash screen is made so you can just change the texture here for another splash that you want. So yeah, this is gonna be like the core skeleton for your games, so you don't have to be worrying about those things every time. I'm gonna use this kind of technology, so yeah, I hope to share it with you soon, and that you can use it and that you can learn from it. Yeah, I guess that's really all. So that's it. Thank you so much. As you know, I'm Freeman. I do open source content and I help people when I can. Me culpa de bici in my hair. And I don't know, I like Godot and I like making games and helping people. So yeah, if you wanna follow me or support me, remember to follow for Joshua Freeman on Mastodon or supporting me on Coffee or Liberapai. So thank you so much to everyone. See you later.